Nekomatsan Paides. Welcome back to my channel. In this video, we're going to discuss sampling distribution of the sample means. Objectives. Number 1. Identify sampling distribution of the sample means. Number 2. Construct sampling distribution of the sample means. Let us first define sampling distribution. A statistic, such as the sample mean or the sample standard deviation, is a number computed from a sample. Since a sample is at random, every statistic is a random variable. It varies from sample to sample in a way that cannot be predicted with certainty. As a random variable, it has a mean, a standard deviation, and a probability distribution. The probability distribution of a statistic is called its sampling distribution, and the standard deviation of this statistic is called the standard error. How to construct a sampling distribution of sample means. There are 3 steps. Step number 1. Given a population and sample size, list all the possible samples. Step 2. Draw a table with 2 columns. In the first column, write all the possible samples. In the second column, write the sample mean represented by X bar. To get the sample mean, just add the sample values, then divided by the sample size n. And step 3, draw another table showing the sample mean X bar, frequency, and the probability of the sample mean represented by P of X bar. To get the frequency, just count the number of times the sample mean occurs. Then determine the probability by dividing the frequency of the sample mean and the total number of sample means. Let us have an example. A population is consist of 2, 3, and 4. List all possible samples of size 2 which can be drawn with replacement from this population and compute the mean of each sample. Before we start listing all possible samples of size 2 which can be drawn with replacement, let's determine the number of all possible samples. How are we going to do that? We're going to apply your lesson in grade 10. That is the fundamental counting principle. Using the fundamental counting principle, it will allow us to find the number of unique ways that a combination of events can occur by simply multiplying the number of options for each event. In our situation or in our example, how many events are there? So based on the given, you have a sample size 2, so that means there will be 2 events. So we're going to take 2 from our population. Okay, so we have sample 1. In sample 1 or event 1, there are how many options? Since we're going to take it from our population, and there are 3 numbers here, so that means event 1 has 3 options. How about event 2? Or sample 2, how many options do you have? Okay, we have a clue here with replacement. So that means there is a repetition. So after you take 2 as your sample 1, so you can still take it as your sample number 2. Or can have 3 and 4 as sample 1 and sample 2. Okay, so that means there are still 3 options for event number 2. So you're going to multiply that. So you have 3 times 3. So that means the number of possible samples is 9. So there are 9 possible samples. So to check if we are correct, we're going to list all the possible samples. So let's start with 2. So you can have 2 and 2. We can have 2, and 3, we can have 2 and 4. Okay, and okay, there's no other pair for 2, so we're going to go with 3. So we can have 3 and 3, 3 and 4, 3 and 2, right? Next, how about, okay, 4, so we can have 4 and 4, 4 and 3, 4 and 2. Okay, so there are how many possible samples? So there are 9. We are now in step number 2. You're going to draw a table showing the samples and its mean or average. From step number 1, we have the samples 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, 3, 4, 4, 2, 4, 3, and 4, 4. So I arrange these samples. Next is we're going to get the mean. So to get the mean, you just add the sample values divided by the sample size. So sample size is 2. It is very easy, okay? So just follow. So first sample, you have 2 plus 2 divided by 2. The answer is very obvious, no? That's 4 divided by 2, so you have 2. I think you can answer it without showing. Just answer it mentally. Okay, let's have 2 and 3. So add 2 plus 3 is 5 divided by 2. So you have 2 and 1/2 or 2.5. Next, you have 2 plus 4, that is 6 divided by 2. So you have 3. 3 plus 2, 5 divided by 2, 2.5. 3 plus 3, answer is obvious, you have 3. 3 plus 4, that is 7 divided by 2, so you have 3.5. 4 plus 2 is 6 divided by 2, that is 3. 4 plus 3 is 7 divided by 2, that's 3.5. And 4 plus 4 is 8 divided by 2, so you have 4. Step number 3. We're going to draw a table showing the sample mean x bar, the frequency, and the probability p of x bar. In our previous table, or in step number 2, we already determined the sample means. Let's now write it in the first column. Now you're going to write it once. But if that sample mean appeared twice, you're going to write the frequency 2. If it appeared thrice, so you're going to write the frequency 3. Okay? So we're going to write in ascending order. You start with 2. Next is 2.5. That's that. And you have 3, 3.5, and 4. Okay, we're going to write here the total frequency. So, how many times does 2 sample mean 2 appeared? So, once only. You can check the table later. 2.5 appeared twice, so you write 2. 3 appeared 3 times, and 3.5 there are 2, and 4 there's only 1. So what is the total frequency? So this is the number of all possible samples. So there are 9. Now, to get the probability, just divide the frequency of the sample mean and the total frequency. So there is 1 out of 9, so that's 1 over 9. Here you have 2 over 9. Here you have 3 over 9, or you can simplify that by dividing 3 in the numerator and denominator, because that is the greatest common divisor, right? So this will become 1/3. Then you have 2 over 9 and 1 over 9. Now if we're going to add all these probabilities, that is equal to 1. So this is now your sampling distribution of the sample means.